Okay, I need you to pause the video and cut out all of these dotted lines. You're going to cut all of the dotted lines, and then you're going to glue down where it says glue down here at the bottom of the toolkit. So pause the video for a minute, and you can go ahead and glue those down, and then press play after you have done that. Okay, today we're looking at radicals or roots. You should be familiar with square root. Roots and radicals are the opposite of exponents. Roots or radicals are the opposite of exponents. Okay, a radical is this check mark sign like this. That is the radical. The expression that is under the radical is called the radicand. And the little number that is sort of inside the check mark box is called the index. The index tells you what root you are taking. So the index is the number that's going to be sort of like the opposite of the exponent. Okay, so we have seen, you have used square root before. You should be familiar with square root. What does the square root mean? It means what number can you square or multiply by itself? What can I multiply by itself or square to get the radicand? So you'll notice for a square root there is no index. So let's think about what you think the index would be if there is no index written. What do you think the index would be if there is no index written? Since it is square root, the index is 2. So if the index is 2, you do not have to write it. If the index is 2, you do not have to write it. Okay, and then we have when there's a little 3 inside the check mark, that is called the cube root. It means what number can I cube to get the radicand? Okay, so we have square root, cube root after that. It's 4th, 5th, 6th, 7th, 8th root. So this we would just say 4th root. The 4th root. What can I multiply by itself and by itself and by itself to get the radicand? Now, make sure you say these correctly. Notice we would never say 4 square root. It is the 4th root. It is not the square root. Or we would never say 3 square root instead of cube root. 3 square root is going to be a totally different thing. Okay, so make sure that you say this correctly. This is the cube root. This is the 4th root. We have the 5th root. The 5th root would mean what could I raise to the 5th power to get the radicand? The 6th root would mean what could I raise to the 6th power to get the radicand? Okay, I am expecting you to memorize all of these at the bottom. Hopefully you already know a lot of them. So I've made it so that you can kind of quiz yourself. If you've cut all these dotted lines, you could flip up each of them to check. Okay, so underneath, so I need for you to write underneath what each of these would be. 1 squared, underneath that you could put 1. 2 squared, underneath that we know is 4. 3 times 3 is 9. 4 times 4 is 16. Okay, so unfold these and write this underneath. I would assume that up to 12 you know very well already. 5 squared is 25. All of these numbers here I want you to be familiar with are called perfect squares. What does that mean? That means we could take the square root of them. So the square root of 25 is 5. 6 squared is 36. 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. Those should be, you should be familiar with those. It might get a little bit more challenging to remember as we get bigger numbers. You must memorize that 11 times 11 is 121. 12 times 12 is 144. Okay, you need to have those memorized. Okay, you might not be as familiar with these, but you need to become familiar with these. 13 squared is going to be 169. 14 times 14, you just switch around this 6 and 9 to get 196. So that's how I remember those. Switch around the 6 and 9 for 13 squared and 14 squared. Okay, you absolutely need to know that 15 times 15 is 225. Hopefully you can remember if it's multiplied by 5, it's going to end with a 5. And 16 times 16 is 256. Okay, some of these might be a little bit harder to memorize, or they might all be hard to memorize depending on what you already know, but you need to know all of these. Up to 16. Then we're going to get to the perfect cubes. So let's look at what is 1 times 1 times 1. 1 cubed is 1. So these are going to be perfect cubes. You'll notice 1 is a perfect square and a perfect cube. 2 times 2 times 2 is 8. 3 times 3 times 3. Okay, let's look at what 3 times 3 is. 3 times 3 is 9. Times 3 is going to be 27. 4 times 4 times 4. That 4 times 4 gives me 16. If I multiply by 4 again, I get 64. Okay, you need to know your perfect cubes here. 5 times 5 times 5. 5 times 5 is 25. Times 5 again is 125. Okay, you need to know 6 times 6 times 6. 6 times 6 is 36. If we times 6 again, we're going to get 216. Okay, I'll just make you memorize the perfect cubes up to 6. And then to the fourth power, 1 times 1 times 1 times 1. 2 times 2 times 2 times 2, you need to know. Okay, so we've got 2 times 2 is going to be 4. 4 times 2 is going to be 8. 8 times 2 is going to be 16. Okay, so you need to be familiar with those. Okay, then we have got 3 times 3 is 9. Times 3 again is 27. And 27 times 3 again. You got to multiply it by 3 again to get 81. Okay, we've got 4 times 4 gives me 16. Times 4 again gives me 64. Times 4 again is going to give me 256. Okay, you'll notice that 16 squared is the same as 4 to the fourth power, which kind of makes sense if you think about it. Okay, and then 5 to the fourth power, we would take that 125 and multiply it by 5 again to get 625. So you need to be familiar with all of these. You need to memorize all of these perfect squares, perfect cubes, and perfect fourth powers. Okay, on the back, let's talk about roots of negative numbers. Okay, you'll notice this is the square root of negative 4. That would mean what number can I multiply by itself and by itself again to get negative 4? Okay, well, can I do 2 by itself, multiply 2 by itself to get negative 4? Can I multiply negative 2 by itself to get negative 4? Would that work? No. And if I did negative 2 times positive 2, that won't give me a negative 4, so no. I cannot take the square root of negative 4. Okay, cube root of negative 8. That means what can I multiply by itself So 3 times to get negative 8. Let's see if this is possible. Okay, can anybody think of a number that I could multiply by itself 3 times to get negative 8? Is negative 2 times negative 2 times negative 2. This gives me positive 4. Positive 4 times negative 2 does give me negative 8. So it actually does work to take the cube root of a negative number. It does not work to take the square root of a negative number. Do you think we can take the fourth root of a negative number? Let's see if there is a number that I can multiply by itself 4 times to get negative 81. Okay, I know that 3 times 3 times 3 times 3 gives me positive 81. But I need all the same number. If I did negative 3 times negative 3, that gives me positive 9, negative 27, positive 81. Is it a possibility? No, it is not. And the fifth root of negative 1 means what number can I multiply by itself 5 times to get negative 1? Okay, let's see if negative 1 times negative 1 times negative 1, 5 times would give me negative 1. This gives me positive 1, negative 1, positive 1, negative 1. So negative 1 does work. Hopefully you notice the pattern that you can take odd roots of negative numbers. You can take odd roots of negative numbers. And hopefully you notice that your answer, if you take the odd root, if you take the root of a negative number, your answer will be negative every time. Okay, we're going to do something called simplifying radicals, okay? And I'm going to show you 2 ways to do this. And I sort of do a combination of the 2 methods. I sort of use this method for numbers and this method for letters. One method is to break down into prime factors and circle groups of whatever the index is of the same number. Okay, let's look at what that means. I need to take the radicand and break it down into prime factors. Okay, you've probably done factor trees before, so I need to figure out what could I multiply to get me 16. I could do 2 times 8 is one way I could get 16. Okay, and you also could have done 4 times 4. Okay, keep going until all factors are prime, and 8 can be broken down even more. So I'm going to break that down into 4 times 2. Make sure you bring all of your factors all the way down to the bottom. And I could break this 4 down into 2 times 2. Okay, so you make a factor tree of all of the prime factors. Next it says to circle groups of whatever the index is. So what is our index in this question? This said the cube root of 16. So the index is 3. So since the index is 3, I'm going to look for a group of 3 of the same factor. And you should notice that I have 3 of this same number. Okay, anything that there is a group of 3, or a group of whatever the index is, we are going to put this on the outside. We're going to write it once on the outside. Okay, so if there's a group of 3, we're going to write once outside the radical. When I say outside, I mean outside the radical. Okay, then I'm going to do the radical, and I'm going to make sure that this 3, I have the same index in my answer as I do in the question. I'm going to make sure the 3 is sort of inside the check mark, so I know it's not an exponent for that 2. And this 2 is going to stay on the inside. So this is the answer. Okay, this means that I am the cube root of 16 is the same as 2 times the cube root of 2. Now, people often ask me, how do you put a cube root into the calculator? And I do want to show you that because it might come in handy today. Okay, to get the cube root in the calculator, you might want to grab your calculator and try this. You're going to press Math, And you should notice that option 4 is the cube root. Okay, so the cube root of 16, 16 is not a perfect cube. This is the cube root of 16. It should be the same as 2 times the cube root of 2. 2 times the cube root of 2. Notice these are the same thing, but this one is considered simplified. Okay, let's try another one. 50, this is the square root of 50. So what is my index if there's not an index written? The index is 2. Okay, so I'm going to break down 50. I could do 5 times 10. You could have done 2 times 25. It does not matter. You should get down to the same prime factors. 10 can break down into 5 times 2. Since the index is 2, I'm looking for groups of 2 of the same number. Here's a group of 2 of the same number. So I'm going to write that once on the outside, and this 2 is going to stay on the inside. Okay, if you put a 2 here, that is not incorrect. That is fine. Okay, this is a simplified version of the square root of 50. So for example, if we take the square root of 50, it should give us the same thing as 5 times the square root of 2, but in a more simplified version. They're the same. Neither of them are perfect squares, so that's why we get this ugly decimal, but this is considered simplified. All right, let's try one more. Notice it should stand out to you that we have a negative. We're taking the cube root. So since there is a negative, we said that you can take the odd root of a negative number, and we said when you do that, your answer will be negative. So I'm just going to put a negative in my answer, and then I'm going to kind of forget about it. Okay, I'm going to break down 24. There's several ways you could break down 24. One way would be 6 times 4, but there's other ways you could have done that. Okay, keep going until you're all the way down to prime factors. 6 breaks down to 2 times 3. 4 breaks down into 2 times 2. Okay, and then I don't have any other prime factors. Since my index is 3, I'm going to look for a group of 3 of the same number. When I have that, I'm going to write it once on the outside. And this 3 is going to remain, this 3 that anything that didn't get circled remains on the inside, okay? And this is my final answer. Or is it my final answer? There is something wrong with my answer. I want to see if you know what it is. Do you know what's wrong with my answer? Hopefully you noticed that I had a cube root in my question, so I need a cube root in my answer. Negative 2 times the square root of 3 would not give me the same thing. Okay, so you should notice if I take math, if I take the cube root of negative 24, that should give me the same thing as negative 2 times the cube root of 3. Okay, except the one at the bottom is more simplified. By the way, if you wanted to do a 4th root or 5th root or 6th root, you would press 4 and then this option. Like if you wanted to do the 4th root, you would do 4 and then math 5, and it would tell you that that is the index. Okay, so that's one way you could break them down, the simpler way. Here is another way you can break them down. You really can only do it with numbers. You'll see we have some letters at the bottom here, so you can't use that method here. Okay, what you can do is you can look for perfect squares or cubes that can be multiplied to get the radicand. This is why you need to memorize all of these. Okay, if you have all of these memorized, this is what you can do. So for example, we have the cube root of 16. This is the same question, so we should get the same answer. But what I'm going to do is I'm going to think about my perfect cubes. I know 1 is a perfect cube. I know 8 is a perfect cube. And 27 is a perfect cube. If you notice, 8 goes into this. So I could break this down as the cube root of 8 times the cube root of 2. I'm breaking down the 16 into 8 times 2. Now, why do I want to do that? Because I know that 8 is a perfect cube. And I know that the cube root of 8 is 2. So I could, the cube root of 8 is just 2, and I can multiply 2 times the cube root of 2 to get that final answer. Okay, that's the same answer we got before. Same thing with square root of 50. This time we're going to think about all of our perfect squares. You should know your perfect squares are 1, 9, 1 times 1 is 1, so 1, 4, 9, 16, 25. And I notice that 25 goes into 50. So I'm going to break this down as the square root of 25, and 25 times 2 is 50. Okay. Why did I want to do that? Because 25 is a perfect square. What is the square root of 25? It is just 5. So I could do 5 times the square root of 2. That's the same answer. So you'll notice this way might be a little bit shorter. The only problem is, like I said, you need to make sure you have your perfect squares and cubes and fourth power memorized. Okay, I'm going to do the same thing here. I can take the cube root of a negative number. I'm going to just sort of put the negative outside and then sort of forget about it. And I'm going to think about perfect cubes that go into 24. Okay, you do need to have your perfect cubes memorized. So I have 1, 8, 27, 64. Let's see if any of those can multiply. And you should know that 8 can multiply into 24. So I could break this down into the cube root of 8 times the cube root of 3. Because 8 times 3 gives me 24. And I broke this down. Why did I want to do that? Because 8 is a perfect cube. And I could take the cube root of 8. What can I multiply by itself 3 times to get 8 is 2. And then times the cube root of 3. Okay, so we got the same answers. We just used 2 different methods. Okay, now we're going to do some challenging ones. And I'm going to do number 1. I can break this down. I'm just going to do this, I'm just going to do all of it using this method here. But if you want with the numbers, you can use this method as sort of a shortcut. Okay, so this is the cube root. So I'm going to be looking for groups of 3. I'm going to break down the 54 as much as I can. So 54, there's several ways to break it down. You could do 9 times 6. The numbers that are closest together will keep you from making the biggest trees, if you know what I mean. Okay, I could break down 9 into 3 times 3. I could break down 6 into 3 times 2. Okay, and then I'm going to see if I could break any of these down anymore, but I cannot. So make sure you bring down everything from the tree into one big line. Then I want to see what x to the 4th power is. I'm just going to expand that. That's x multiplied by itself 4 times and y multiplied by itself 6 times. 1, 2, 3, 4, 5, 6. Okay, I'm going to look for groups of 3 of the same thing. Here is a group of 3, so I'm going to write that on the outside. Here is a group of 3 of the same thing. I'm going to write that on the outside. Here is a group of 3 on the same thing and 3 of the same thing. So 3x, y, y. What do you think I'm going to do with everything if there's more than one term on the outside? I am going to multiply if there is more than one term. Then let's see what's on the inside. On the inside, I've just got a 2 and I've got an x that are stuck on the inside. Okay, so I can multiply this 3xy squared times the square root of 2x. It's very important, oh, it's not the square root, is it? I forgot to put my index. It's very important that I could tell the difference between if something is an index of whatever variable, it's very important that I make sure I know what an exponent is and what the index is. Always check if you had a cube root in your question, you should have a cube root in your answer. I almost forgot that. Okay, number 2 is just the square root of 200. Okay, I could break this down. Let's do 25 times 8. But there are several ways you could break down the square root of 200. 25 breaks down into 5 times 5. 8 breaks down into 4 times 2. Okay, I could break the 4 down. Make sure you bring everything down into a nice line. Bring everything down into a nice line. And then I have x multiplied by itself 5 times and y multiplied by itself 4 times. Okay, what is my index if there is not an index written? It is 2, so I need groups of 2 of the same thing. Here's a group of 2 5s. I write everything I circle, I write once on the outside. I write the 2 once on the outside, and when there's more than one thing, I'm going to multiply. Okay, we have a group of x's, a group of x's, a group of 2 y's, and a group of 2 y's. Okay, and let's see what is left on the inside. There is a 2 and an x on the inside. Alright, so 5 times 2 would be 10. X times x is x squared. Y times y is y squared times the square root of 2x. Make sure I can tell what is the index and what is the exponent if there's an index or an exponent beside each other. So I have simplified this radical. Okay. And lastly, number 3. The negative, I'm just going to keep in mind that I can take the cube root of a negative number. I'm just going to put a negative in my answer and then sort of forget about it. I'm going to break down 250 into 25 times 10. I could break that down even more into 5 times 5. 10 I'm going to break down into 5 times 2. Okay, I see if I could break any of those down anymore, and I cannot, and I make sure that I bring everything down into a nice line. Okay, I have got 9 x's, 4, 5, 6, 7, 8, 9, and I've got 5 y's. Okay, I am looking for groups of 3 of the same thing. Here is a group of 3 5s, so I'll write 5 once on the outside. I have 1, 2, 3 groups of x's, and I have 1 group of y's. Okay. And let's see what's left on the inside. On the inside, I've got a 2 and a y and a y. And what is wrong about this? Make sure you put the index. It will be wrong if you do not have the correct index. Okay, so this is negative 5 x to the 3rd power y times the cube root, and make sure I can tell that that 3 is the index and not an exponent for that y, times 2y squared. Okay, believe it or not, this is considered simplified versus this, which is kind of funny because to me this looks a little simpler than this. But the rule is this is how we have to simplify our radicals.